The code of Mashup functions as the complete control system of the game, handling everything from question creation to scoring and resolve. At the beginning, the program uses the random module to ensure that all math problems, operators, values, and answer choices are generated unpredictably, which prevents repetition and keeps the gameplay challenging. The code defines restant values that determine how many questions being are prepared and how many are asked per game, allowing the developer to control difficulty, pacing, and game life. The generate function plays a central role by creating math problems based on the player's chosen difficulty level and question type. For easy mode, it produces basic arithmetic problems with missing elements, while medium mode introduces blue expressions that requires deeper computation. In hard mode, the function dynamically selects from algebra equations, fraction equations, percentage calculations, and multi-step word problems, ensuring advanced logical reasoning. This function also formats questions differently depending on whether the player selects fill in the blank or multiple choices, and it returns both the question text and the correct answer for verification.
Beyond question creation, the code also manages question organization and purpose recreation of question called function, which builds a large collection of possible questions for game mechanics. This approach guarantees randomness and prevents players from memorizing patterns, as each game session draws in a subset of questions. The play game function is responsible for executing the actual game experienced by each variable. It collects user preferences to display questions sequentially, accepts player input, limits attempts and checks answers against correct solutions. This function also updates the player's score in real-time timeline and provides immediate feedback, reinforcing learning by informing the player whether their answer is correct or incorrect. Additionally, it includes a quit option that allows players to exit the game gracefully without crashing the feedback.
The main section of the code functions as a game manager, directing how the program runs depending on selected game mode. It distinguishes between single-player and two-player modes, calls the play game function for its participant, and compares score at the end of multiplayer session to determine the winner of a declared tie. Overall, the code functions not only as a game engine, but also as an educational system that integrates logic, conditional loops, and modular functions to create an organized and interactive experience. Each part of the code works together to ensure smooth gameplay, accurate scoring, controlling difficulty progression, and meaningful player interaction, clearly demonstrating structured programming and problem-solving beyond simple command line game. The code also functions as a system that enforces rules, consistency, and fairness during gameplay by limiting the number of attempts per question and immediately checking the user's input against the correct answers. The programs ensures that scoring is accurate and unbiased. This prevents players from guessing repeatedly and encourage careful thinking before answering. The built-in quiet option allows the user to exit the game safely at any time without disrupting and program flow, showing proper control handling and user-centered design. This feature helps maintain smooth execution and prevent errors that could otherwise interrupt gameplay. Furthermore, the code serves as an assessment and feedback by displaying correct or incorrect messages, and revealing helps players understand the program, helps players understand their errors, and improvement their problem-solving skills. The final score display summarizes performance and in two-player mode introduces a competitive element that motivates engagement and reliability. Overall, this part of the value of the game by combining evaluation, feedback, and motivation within a single structured program.